In this video, we're going to do another balancing example where we're also going to review how we actually come up with the formulas for the chemicals that we see in the balanced chemical equation. So first off, this one says a carbonic acid solution and aqueous calcium iodide react to form solid calcium carbonate and hydroiodic acid. So first up, we have a carbonic acid solution. So carbonic acid, that ic means that the polyatomic ion ended with 8. So the acid nomenclature rule is 8 turns into ic. So that means carbonic acid must have been referring to carbonate, which is a polyatomic ion you need to memorize. It is CO3 2 minus. And then since it's CO3 2 minus and acids have hydrogens attached to them, we're going to need 2 hydrogens to make a neutral compound with CO3 2 minus. So carbonic acid would be H2CO3. And since it says it's a solution, we'll go ahead and call it aqueous for the physical state. Next up, it says an aqueous calcium iodide. So calcium, just looking over at our periodic table, calcium is right here. It's in the second column, and it's a metal. So metal meaning it's going to be positively charged. And since it's in the second column, it has 2 valence electrons, so it'll have a 2+ charge. And then iodide is referring to iodine, which is over here on our periodic table. So iodine being a halogen, just 1 valence electron away from a complete outer shell. It wants just 1 electron, so it's going to have a charge of 1- when it's an ion. So then, to form a neutral compound, you want to think to yourself, how many iodine am I going to need to balance with 1 calcium to make a neutral compound? We're going to need 2 of them, so calcium iodide, Cai2. And it does say aqueous right there, so we'll go ahead and label it aqueous for the physical state. And then the word react came next, so we just do our reaction arrow. And we are forming solid calcium carbonate. Okay, so calcium again is the Ca2+, carbonate is the CO3 2 minus. And we would need 1 of each since they both have a charge of 2. Calcium carbonate, CaCO3. We only need 1 of them to make a neutral compound. And then they did say solid right here. Okay, next it said, and hydroiodic acid. So hydroiodic, the hydro in front means it's one of those binary acids. So like HF, HCl, HBr, HI. So the acids that form with the halogens. So hydroiodic would be this one. So HI. And then the word acid tells us that it's dissolved in water, so we can label it aqueous. Okay, next up for balancing. So I'm going to go ahead and use that column technique. So I'm going to list off all of the elements that I see. So there's hydrogens, carbon, oxygen, calcium, and iodine. On the left side, I see 2 hydrogens and 1 carbon and 3 oxygens, 1 calcium, and 2 iodine. And on the right side, I see 1 calcium, 1 carbon, 3 oxygen, 1 hydrogen, and 1 iodine. So checking out, what's not balanced, I see the iodine and the hydrogens are not balanced, but everything else is okay. And since we need 1 additional hydrogen and 1 additional iodine on the right side, we could just put a 2 in front of the hydrogen iodide, and that would be it.